So, good evening, gentlemen, and whoever watches these videos. I have bought something new for my car. It's an HID conversion kit, or high intensity discharge lights, for my extra lights. And I've done this because mostly it's just fun to doodle around, but also because in Sweden it's quite dark during the winter half. So I bought this as a replacement in my extra lights from the ordinary halogen tungsten based light bulbs. And there are quite a few different things that you can do to get better lights. Either you can buy more high power halogen lights, for instance, light bulbs that are 100 watts or more, or you could get like a LED extra light bar, even this bar thing, or the round ones, or whatever, or just the light bulbs themselves actually come as LED light bulbs right now. If you want that, try that out. Or you can buy these discharge lights. And the main difference between this discharge and a normal halogen based tungsten based light bulb is that this one has no filament. I don't know if you can see it. I'll see if that comes through. But it actually arcs inside of that bubble. And inside of that, there are some xenon, sorry for the pronunciation, gas that gets excited by the current that flows through it. So these lights burn extremely bright and also quite cold in comparison to ordinary halogen lights. So they're very efficient lights. This is a 35-watt discharge light, and there are people talk a bit differently about this, but some say that 35 watts is like 90 to 100 watts of halogen power. So I quite like it. I'll see if that's true. It also has a kind of high Kelvin number, so it's a very blue-ish, light blue color to it, which gives a good color or contrast when you drive, so you can see stuff at the road much better. And when it's snowy outside like it is right now, it bounces and reflects off the snow very nicely. The other main difference between a high intensity discharge light and a tungsten based light is that with an ordinary light bulb, like that you have in your car or in your house or whatever, it only takes what voltage it's needed to start it. In a car, it's 12 or 24 volts. In your house, it's 110 to 220 volts, depending on where you live. And that's all you need. You just need 12 volts from the battery, and the light will start to shine. These are a bit tricky because, as I said, there are no filament inside, so you need to have an arcing, and then to keep that arcing going inside of the light bulb. And that's why they have these big ballasts and driver circuits to make that arcing start in the first place and then continue to arcing inside of that. So when you turn the light on the first time, it does something they call a cold start, which is it blasts a high frequency AC current or voltage at 23,000 volts to start the arc, and then it backs down to about 13.2 volts to keep that arc going, but it's still AC. So this box takes in the DC 12 volts from your car, and first of all it steps it up to the 23 kilovolts needed to start the light, and then it steps down to 13.2 volts, 3.2 amps, and just drives the light so that the discharge thing, the arcing, continues. And I actually tried to start this on camera to show you exactly how that startup works, but that cut my microphone out. The program just crashed that I used to record audio. So I'll see if I can put that in the end, where it doesn't really matter if the audio works or not. But this is how it looks and I hope it works. This one is an H1 light fitting for my extra lights. They come in a variety of these ordinary H type connections or sockets, and also in a few other applications. I just must say, here in Sweden, these are actually illegal to have in your ordinary headlights, but they are fine to use in extra lights. That's no biggie. but you can't use them in your ordinary headlights because the light patterns from these ones are quite different from normal tungsten halogen bulbs. So they mostly scatter their light very much forward and doesn't really interact with the lens too much in your headlights. So when you use these both for daytime running lights or like low beam and high beam, but especially low beam, that's very easy to spot a person that has converted because you will get blinded by them. So that's quite irritating. But I thought we could take a look on the inside of this box and see how well this is put together. I mean, yeah, it's made in China, so and I paid $25, including 2 lights, 2 drivers, and shipping to Sweden. So I don't have too high hopes for this particular thing. But well, we'll take a look, and I mean, it's doesn't really matter if it works for a while and cuts out afterwards. Um, I just want to try it out. If I like it, perhaps I buy a more better kit. Let's see if we can open this up. And there we go. This is the circuit board. And as you know from previous episodes, I have little to none knowledge of how this works. So if anyone knows and can see, look at this and say that this looks quite okay or it looks terrifying, please put it down in the comments. And especially talking to you, Thomas, take a look at this and see if this looks skookum. The only thing I can really understand from this is that you have your, let's see, you have you have your input on this side, the DC from the battery, and it goes through some stuff and a coil and this high power driver, I guess it is, and then it goes out to the light and has some smoothing capacitors and some discrete. It has here. It actually has an Texas Instruments. It's an let's see if I can find that out. HYC 824A. I'll see if I can find out what that is just in one moment. I've checked this Texas Instrument little chip up, and the actual name is Texas Instrument TL494C, and this is a pulse width modulation control circuit, and it also has some other cool features. So that tells me that most likely the light bulb perhaps is PWM'd, or that one is the one that does that drives this transistor to get it to the right. Yeah, that's most likely. I guess this is one makes the DC to AC, I would guess. It also has some over voltage and thermal protection and a feedback. So I guess somewhere in these, I don't know if it's actually hooked up or not. I mean, it's from China. It's not. It doesn't matter if everything's populated, eh? But it has a feedback to see if what it's put out is what it's expecting to get back. So it has some logic. And all these components are soldered directly on this aluminum-based substrate. So in this entire thing is actually a heatsink. And that's quite nice because I tried this out earlier just for a few minutes, and this board gets quite hot. Not hot to the touch, but it gets quite hot. So if this one has a thermal shutoff, as I think I understand the datasheet that it has, then this one will turn the entire circuit off if in the event that the chip gets too hot or everything here gets too hot. So that's quite nice. And the mounting plate to mount it inside of the car is this thing. Yeah, I guess it's a piece of iron. So that's how it looks on the inside. That was basically it. I think that's, well, it will be interesting to see when I have installed this in the car to see how much light they actually put out, if they even fit my extra lights. I'm not sure. As I said, either the light bulb is too long, or I have bought the wrong socket because I'm an idiot sometimes, or a combination of things, or it will fit just straight away. So I guess we will have to wait and see. But as always, thank you for watching. If you like what I do and like this video, please subscribe or not. But if you like it, you give it a thumbs up. That's quite nice to get. Well, have a good day. Bye bye. this is where my microphone cut out because the EMP from the box itself actually cut my mic out. But you can see the startup sequence. It turns quite bright.